All right, in this video, we're dividing these two polynomials. They're already written in standard form, so I'm going to go ahead and put them in the division format that we use. So 3x to the third minus 1 will divide into the dividend 3x to the fifth minus 2x squared plus 3x minus 4. All right, the first step of this process is to ask ourselves, what do I have to multiply 3x to the third by to make it look exactly the same as 3x to the fifth? Well, the answer to that question would be x squared, right? Because x squared times 3x to the third will give you 3x to the fifth. I can determine that by taking the 3x to the fifth from the dividend and dividing it by that first term, 3x to the third of the divisor. And you'll see that the 3's cancel out here, and then x to the fifth divided by x to the third is x to the 5 minus 3, or in other words, x squared. So this x squared is the reason why we have x squared here above. All right, let's multiply this x squared times our divisor to see what that gives us. So x squared times 3x to the third, as we discussed already, is 3x to the fifth. And then x squared times negative 1, of course, is minus 1x squared. So remember, our next step is to draw the line and change the signs of the second polynomial here. And we're going to have 3x to the fifth canceling out with negative 3x to the fifth. And then we have minus 2x squared plus 1x squared would give you negative 1x squared. Then I carry down these remaining terms, and I'll end up with plus 3x minus 4. All right, from here you can see that the degree of this polynomial is lower than the degree of the divisor. So because of that, we can now stop the division process and just call this guy our remainder. So the format of our answer can be written like x squared plus negative 1x squared plus 3x minus 4 over 3x to the third minus 1. And if we want to check that that's our answer, all we have to do is multiply this quotient by our divisor. Let's see if that gives us the dividend we started with. So if I multiply 3x to the third minus 1 times x squared plus a negative 1x squared plus 3x minus 4 over 3x to the third minus 1. Let's see what happens if we do that. Well, the first result I would get is basically 3x to the third minus 1 times x squared. So I can write that out like x squared times 3x to the third minus 1. And then the second result I'll get is basically 3x to the third minus 1 times this fraction, but the reality is that this whole piece will cancel out with this whole piece, leaving just minus 1x squared plus 3x minus 4. Now if I distribute my x squared times my 3x to the third, I'll end up with 3x to the fifth, and then x squared times negative 1 is just negative x squared, and then I have minus x squared plus 3x minus 4. If I clean all that up by combining like terms, I'll end up having 3x to the fifth minus 2x squared plus 3x minus 4, which is our original dividend. So we've shown that this in fact is the proper quotient.